here's the thing. So if you're given, let's say that you're probably given some problem like this in before, where you're supposed to be like, oh, simplify this right here. So then what you would do is you would get a common denominator like this. And then, so the common denominator would be the product of those two. In this case, it's the product. Okay, so you would take each of these fractions. So the first fraction would be this, and the second fraction would be this right here. But then you multiply by a fancy form of 1, which in this case would be, in this case was x plus 4 over x plus 4. In this case is x minus 1 over x minus 1. So you get that, right? And then you distribute this 2 in, so that's 2x plus 8. And then over here it's minus 3x plus 3. And that's all over this right here. And then you get, so 2x minus 3x is negative x, and then 8 plus 3 is 11. Okay, and then you might expand these out right here, right? Okay, or you might just leave it like that. Okay, so the thing is though, this is equal to this. Now the question is, which is easier to integrate? This or that? And the answer is this part. This is much easier. Okay, because this right here, this one, you just use this formula. You just use this formula twice. Use it right here and use it right there. So dx over x minus a is the natural logarithm of x minus a plus c, and you're done. This one, this is harder to integrate. And in fact, to integrate this, you actually have to go, you have to put it in the original form. Okay. So what I say here is if rational functions are split apart by partial fractions. So this is a rational function. Split apart means going from here, from this form, back to that form. What I'm saying right here, they're usually easier to integrate. So this is much easier to integrate than this right here. And then these are useful formulas. And then another note right here, which doesn't happen in here, if the degree of the numerator is greater than or equal to the degree of the denominator, then use long division first. Okay, so that splitting these apart like this is called partial fractions. Okay, so this is partial fractions, or partial fraction decomposition. Is a method of partial fractions. Okay, so let me give you a few examples. So here we have this example. Now this one is similar to the one on the first page. And what you need to do, the first thing is to factor the denominator. Here it factors into x plus 3x minus 2. Okay, that's what it factors into. And now the degree of the numerator is smaller than the degree of the denominator. So what you're going to do to go backwards, what you do is you take something like this and you assume, what you do is you look and see, okay, what terms would include all of the, what denominators would give me this as the common denominator, and it would be this. It would be a plus over that plus b over that. A over x plus 3 plus b over x minus 2. Now this sum right here, the common denominator is exactly this. And this is the most general kind of situation where this is your common denominator. Okay, so that would be the answer to part A. Part B. For this one, what you want to do is, because the degree of the numerator, this is degree 2, and that's also degree 2. So because those are the degree 2, then what you want to do is you want to do long division first. So this is the numerator and this is the denominator out here. So you're taking this and you're dividing by this. Okay, now, so you go, what times x squared is x squared? And the answer is 1. So then you multiply that out. 1 times x squared is x squared. 1 times x is x. 1 times 6 is 6. But then you have to remember to subtract. Subtract this one. So you get negative x minus 6, because x squared minus x squared is 0. So you get negative x minus 6. Okay, and then so that's telling you that this long division is telling you that this is equal to 1, which comes from here. This one comes from here. Plus, and then the remainder like that. Okay, and the denominator here cannot be factored. So when that's the case, then you really can't do much with it. Okay. And so that's pretty much the best you can do, this exactly right here. Now, in general, that's going to be, when you have, when you have a denominator, it's going to factor into linear terms and or quadratic terms, and the irreducible quadratics. This is an irreducible quadratic. Okay. This is an irreducible quadratic. So you're going to get this. And that will be the form right there. That would be the general form without finding these. I guess, of course, we got them from the long division. Okay. Okay, so that would be the answer to those ones. Number 2, more of the same. Write out the general form of the partial fraction decomposition. Do not determine the numerical values of the constants. Okay, so here the degree is 4. That degree is 2. So the first thing that you want to do is long division. Okay, x squared times x squared is x to the 4th. X squared times this is negative 2x cubed, and then x squared times 1 is x squared. Oh, I like that. Okay, when you subtract, then everything here cancels and you just get 2x minus 1. Oh, great. So that means that this is x squared from here plus, and then you have 2x minus 1 over x squared minus 2x plus 1. Okay, now you want to factor the denominator. And it factors into x minus 1 squared. So you think back, what is the most general form that has x minus 1 squared as the common denominator? And in this case, it's going to be this. Okay, so if you have one denominator is x minus 1, the other one's x minus 1 squared, then the common denominator will be this one. It will just be x minus 1 squared. Okay, so you need both of these terms in order to do something like this. Otherwise, you could get into trouble. Otherwise, it won't work. Okay, so that would be the answer to that one. Okay, part B. The numerator is degree 2, the denominator is degree 3. So let's go ahead and let's proceed with this one. Here you can factor an x out, and you get x squared plus x plus 1. And this one's an irreducible quadratic again. Okay, so the way to handle that one is like this. Okay, so you have, so if to get this as your common denominator, you, the most general form will look like this. This one, okay, since this is a quadratic, then it would be bx plus c. Okay, so when you have a quadratic, then you have two terms that you have to have in the numerator, bx plus c. When it's just a linear term, you just have a constant in the numerator as the most general form. Okay, so this might be confusing now. Hopefully, when we do some exercises all the way through, we'll tie it all back in together. So let's look at number 3. This is the integral of x cubed over x minus 1. And now since the numerator is degree 3 and the dot's degree 1, then we want to divide first. So x squared here, x squared times x is x cubed minus x squared, and we subtract, so this is x squared, okay? So the key is to remember when you're doing long division to subtract here. So you get x squared, and then x times x is x squared. X times -1 is minus x. Subtract again, and you get positive x, and so then what, plus 1? Okay, so you remember to subtract at each of these steps right here, and have a remainder of 1. So that means that this integral, or what we're taking the integral of, is this right here, plus this 1 over x minus 1. Okay, so this came from here, and this one come from there. Okay, and then we can go ahead and take the integral. So the integral of x squared is x cubed over 3. The integral of x squared is x squared over 2. The integral of 1 is x. The integral of this one is the natural log of x minus 1. And then the constant. So what you want to do is make sure that you put parentheses around, put absolute value brackets on this one right here. Okay, so just like illustrating where everything came from. That's that, that's that. The one is there, and this one is that one to integrate. Okay, you guys have any questions so far? Okay, great. Let's go to the next one. Okay, here. Here, let's see. So the idea is you want to factor the denominator. And in this case, it factors into 2x plus 1 and x plus 1. Yeah, because 2x times x is 2x squared. 2x times 1 is 2x, plus 1 times x is 3x, and then 1 times 1 is 1. So we have this. Okay, so now you want to do the partial fraction decomposition of this. So finally, I get to show you how to do this. With exercises 1 and 2, it said for something like this, the general form is this. A over the first one plus B over the second one. So this is the most general kind of situation where the common denominator is this product, the product of these two, the common denominator. Okay, so what you want to do is you want to multiply both sides by this common denominator. Okay. So multiply each term by 2x plus 1 and x plus 1. Okay, and when I do that, this, multiplying this by this, all of these just cancel, and you just get 2. Over here, when I multiply this by this, the 2x plus 1's cancel, and I get a times x plus 1. And this one, the x plus 1's cancel, and I get b times 2x plus 1. Okay, now here it's important to remember that we are not trying to solve this for x. Not trying to solve for x. Okay, this should work for all values of x. So what you do is you set x equal to nice values. You look for nice values that you can set x to that will help you find a and b. Okay, so choose nice values of x. To quickly find a and b. I guess maybe I just assumed maybe that you guys were in a hurry when you're trying to do these things. You want to get done as fast as possible. So I'm just going to assume that, okay? Because maybe it's not true, but I'm just going to assume it. Okay, so anyways, if you choose x equal to -1, then that will wipe this whole thing out, right? And the left-hand side will be 2. This will be a times 0. Okay, so I like when things are 0 because it just goes away. And then b times, if I put a -1 in here, I get negative b. So b is going to be -2. Okay, and then that's from setting x equal to -1. And then what you can do is you can set, if you can wipe this one out by setting x equal to -1/2. You still have a 2 on the left-hand side, and then this becomes -1/2 plus 1. And then this just gets wiped out because when you put -1/2 in here, that goes away. So this is 1/2 a is 2. That means a has got to be 4. Okay, and so armed with that information, armed with that and that, then we can come back to here, and this integral becomes integral from 0 to 1 of, and then a, which is 4 over 2x plus 1, and then b is -2, so that's -2 over x plus 1. Okay, so what happened here? So what happened was I put this in for b, and I put that in for A. And then this over here. Okay, so A became 4, and there already is 4 over x, 2x plus 1. B became -2, so that's -2 over x plus 1. Wait a minute. Sorry, 4 over 2x plus 1, and then B over, which is -2 over x plus 1. Okay. And then comes the favorite part, which is integrating. And here you're going to get the natural logarithm of 2x plus 1. If you differentiate this, you'll have 1 over it, 2x plus 1 times the derivative of this part, which is 2. But we wanted to get a 4, so just add a 2 there. And then here, the natural logarithm of x plus 1. Here, you can change the absolute values to parentheses in this case because you're only looking at values of x between 0 and 1. When x is between 0 and 1, both of these are positive, so that you're okay. And you're integrating from 0 to 1. Okay, so put a 1 in first. 2 log, if I put a 1 in here, I get 3. And if I put a 1 in here, I get 2. Okay, minus. Now put a 0 in, so I get 2 log of 1 minus 2 log of 1. Okay, so log 1 is 0, so those go away, and we have 2 log 3 minus 2 log 2. I can factor a 2 out, and then probably it would accept that answer, but if you use logarithm properties, you can just write it like that. 2 times the natural log of 3/2. Okay, so that's basically how, that's the standard beginning partial fractions problem. Okay, level 1. Okay, you ready for something harder? Oh wow, this is much harder. Okay, so here, the numerator is degree 2, the denominator is degree 3. So this is, you don't have to do long division, okay? And the denominator is all factored for you, so that's great. So we'll go ahead and do the most common form that will have this as the common denominator is this. A over y plus b over y plus 2 plus c over y minus 3. Okay, and then this sum right here, the common denominator will be this product. That's the most general way that you can do it without mixing terms. Okay, so mixing terms, like if you had an a over y times y plus 2, that's not, they have to be separate, okay? Or they can be separate. So this is the most general one that'll give it to you. Okay, so multiply everything by each term by this product. And when you do that, on the left-hand side, you're going to get 4y squared minus 2y minus 12. On the right-hand side, you're going to get a times y plus 2 times y minus 3 plus b times y minus 3 plus c times y plus 2. Okay, and then you choose strategic values. So if I set y equal to 0, then that wipes this one and that one out, and it makes this a and it makes the left-hand side -12, and the right-hand side will be, this will be 0 plus 2, so that's going to be 2 times -3, that's -6a. So that means that a is going to be 2. And then if I set y equal to -2, then these two terms get wiped out. And over here I have what? 4 times -2 squared minus 2 times -2 minus 12. And on the right-hand side, I just have the b. -2 in here, I'll put -5 in there. So that's -10. B equals, what is that, 4 times 16 minus 16 plus 4 is 20, minus 12 is 8. Oh dear. So B is actually -4/5. And then if I set y equal to 3, then it wipes those two terms out, and I have 4 times 3 squared minus 2 times 3 minus 12 equals c times 3 times 5. So that's 15c is equal to, let's see, 9 times 4 is 36, minus 6 is 30, minus 20. What? This is red. -36 minus 6. Oh, wait, I made a mistake here. This is plus. $36, oh, that's 18, I'm sorry. 36 minus 6 is 30, minus 12 is 18. So C would be, dividing both of these by 3, you get 6/5. So you get those values. Okay, so what you're going to do is plug each of these in to the corresponding slots, and you have an integral from 1 to 5. Oh, it's a 2, not a 5. Okay. 1 to 2, integral from 1 to 2 of, okay, so A is 2, so that's 2/y. And then B is this, so 4/5, so that's 4/5 over y plus 2. And then C is 6/5, so that's 6/5 over y minus 3 dy. And then just go ahead and integrate. This is 2 log y plus 4/5 log of y plus 2 plus 6/5 log of y minus 3. Okay, and that's evaluated from 1 to 2. So put a 2 in first. So 2 log 2 plus 4/5 log, you're putting a 2 in here, you get 4, plus 6/5 log of, okay, absolute values. So if you put a 2 in here, you get 2 minus 3, that's -1. So that's an absolute value of -1 is 1. Okay, so that's that one. Okay, now you subtract, put a 1 in and subtract. So that gives you 2 log 1 plus 4/5 log 3 plus 6/5 log, you put a 1 in here, you get -2, which is absolute value is 2. Okay, so if you simplify all that, you get 12/5 log 2 minus 4/5 log 3. Because log 1 is 0, so those just go away. And then this one is log 4 is 2 log 2. Okay, because let me show more steps just in case. because that floor is 2 squared and the 2 comes out in front. So you use that right there. And then, so you have everything in log 2 and log 3, and then you just go there. Okay. Any questions on that or anything that we've done so far? Okay, let's do number 6. Okay, so for this one, again, it's factored. This is degree 3 down here. This is degree 2. So we don't have to do long division. So the most general form would be this right here. When you have a squared term like this, you need to have the squared term in there, but then you need to have it just to the first power. So if you had if it was the third power, then it would be you'd have to have the first power, the second power, and the third power. Okay, and then this is just by itself, so I just need that. Okay, so that's the most general form. So when you multiply both sides by this common denominator, it gives you x squared plus x plus 1 equals, so multiply everything by the common denominator, you're going to have a times x plus 1 times x plus 2. That's multiplying this denominator by this. Multiplying this one by this one would give you just b times x plus 2. And then multiplying this one by this denominator would give you c times x plus 1 squared. Okay, now when you start choosing things, so first of all, you're going to choose x. If you choose x equals -1 or -2, then in both cases, this guy goes away, but let's just go ahead and choose those. So if you choose -1, so this is going to be, the left-hand side will be 1 minus 1 plus 1, and the right-hand side will be, that and that goes away, so it's just going to be b times -1 plus 2. So that's negative b equals, so b is -1. Yay. And then if you choose x equal to -2, then over here you have 4 minus 2 plus 1. And then over here, that and that both go away. So you just have this c. -2 plus 1 is -1. Square that, that's 1. So that's just going to be c. And here you have 3. No. Yeah, 3. So c is 3. Okay, now, we still need to find a. So there's a number of ways to do it. The easiest way is to, because these ones you got like immediately, you didn't really have to deal with, in getting this C, you didn't have to deal with A and B, and getting this B, you didn't have to deal with A and C. But to get, so those are the easiest ones to get. So you do those first. Now, to find A, the easiest way is to set x equal to 0. And then the left-hand side is just going to be 1. And the right-hand side is going to be A times, okay, making these all 0 gives you 2A. And then making that 0 gives you 2B. And then making that 0 gives you C, like that. So you get 1 equals 2A plus 2B plus C. But we know what B and C are, so just go ahead and plug those. We know B is -1, so that's, And we know that C is 3, so go ahead and plug those in. And let's see here. 2A minus 2 plus 3. So A is, 2A is, wait a minute. I made a mistake here. This is positive B. So B is a positive 1. So A is negative 2. Okay. So B is positive 1. A is negative 2. B is positive 1, and C is 3. Okay. So the integral plug a negative 2 in for A, and then a 1 in for B, and then a 3 in for C. Okay, so let's go ahead and integrate. So this one is negative 2 times the natural log of x plus 1. When x is between 0 and 1, this is always positive, so that's good. And then this one right here, the integral is actually negative 1 over x plus 1. I'll explain that in a little bit. And then this one is 3 times natural log of x plus 2. Okay, and that's all going to be evaluated from 0 to 1. Okay, so let me explain that one really quickly. That integral, this integral right here. So a couple of things. First of all, I put it as this formula here. Okay. So essentially, think of it this way: x minus a to the negative n. Okay. And so when you integrate, you add 1, and then it's over negative n plus 1, like that. So you get that. Okay. So if you take the derivative here, then you have this negative n plus 1 come down, it cancels that out, and then subtracting 1 gives you just this. Okay. So that's kind of where this formula right here came from. But in case you're confused by my explanation, which it's almost impossible to be confused by, think of it this way. Right here, if I take the derivative of negative 1 over x plus 1, okay, let's explain this term here. That's the same as the derivative of negative x plus 1 to the minus 1, okay? Because so 1 over something, you can write it as that something raised to the minus 1. And when you take the derivative, you have this negative come down, which will cancel that out. And then you subtract 1 from here, that's negative 2. So that's 1 over x plus 1 squared. So right here. So you take the derivative of this, you get that. Okay. So let's go ahead and move on. So first of all, you want to plug the 1s in. So plugging 1 in here, it gives you log 2. Here gives you minus a half. And 3, putting 1 in here, it gets 3 log 3. Subtract and plug zeros in. You have negative 2 log, and you put a 0 in here, it's log 1. And plug a 0 in here, it's 1 over 1, which is just 1. And then plug a 0 in here, you get 3 log 2. Okay, so the only thing that goes away is this one. So you have negative 2 log 2 and then minus 3 log 2. So that's negative 5 log 2. Okay, then you have minus a half, minus a negative 1. So that's going to be plus a half in the end. And then 3 log 3, that's not likely. So plus 3 log 3. Yeah, so that works. That right there works. Okay, great. So that's number 6. Number 7. Okay, number 7. This is another important. This is an example of when you have a reducible quadratic. So the denominator is x times x squared plus 2. Okay, so that one, what's going to happen there is you'll have an a over x. And then for the irreducible quadratic, because you can't like factor this any further over the real numbers. Well, over rational numbers, I'm sorry. You have to have a bx plus c. Okay. So we'll take this, or rather this, and this, and we'll multiply each of them by this x times x squared plus 2. Okay, so that's going to give us x squared minus x plus 8 on the left. On the right-hand side, we'll have a times x squared plus 2 plus b x plus c times x. So we get that. Okay, so that's a 2 there. So we're going to find strategic values. So if you set x equal to 0, that's the easiest. Let's do it in a different color. Okay, so setting x equal to 0 gives us an 8 on the left. And this goes away, and we just have a 2a over here. So a is equal to 4. Yay. So we got a to be 4. And now we need some more values to set things to. Let's try. So you've used 0. Let's try 1. So just try like small values that can easily plug in and see what happens. Okay. So if you plug a 1 in, then oh great, this is 1 squared, which is 1 minus 1. That cancels, so you just get an 8 on the left-hand side again. The right-hand side, you're going to get, if you plug a 1 into here, that's going to be 3a. And then over here, if that's 1 and that's 1, then you're just going to be b plus c. And then a is 4, so that's 12. So you have b plus c equals negative 4. Okay, because this 12 goes over here as a negative 12, and then b plus c equals negative 4. And then it's okay to have both of these in there, and then just do another value here, maybe x equals negative 1. And that will give you negative 1 squared is positive 1, and then minus negative is plus 1. So they're going to get 10 on the left. And here, this is still going to be 3a. And then here, if you put a -1 here, and that's basically subtracting that. So let's see here, what do we get? 3a is 4, so that's 12 plus b minus c. Okay, so b minus c equals -2. Okay, so again, we have this and we have that. So if we add them together, then we have 2b equals -6. That means b is -3. And then if you plug that into here, you get c equals -1. Okay, so we got everything. We got A, B, and C. So wow, the only question is, do we have enough space now? Probably not. Okay, so put the values in, and we have 4 over x plus, and you have -3x minus 1 over x squared plus 2. Okay, in this case, when it's an irreducible quadratic like this, it's just x squared plus, there's no linear term, then that's much easier to deal with. And what you do is just split it up like this now. And of course, this first one is just going to be 4 log of absolute value of x. The second one is, if you look at the log of x plus 2 and take the derivative of that, you'll have 1 over x squared plus 2 times, and you'll have a 2 coming out, right? So if we just write -3/2, then that will take care of the 2. Okay, this last term right here, where you have 1 over x squared plus 2, that is related to the inverse tangent. And if you look at the first page, then it's this formula right here. So the integral, it's just x squared plus 2 is basically what we have. Except we have a minus. It's the negative of this. Then a is -2 in this case. No, I'm sorry. A is the square root of 2. I meant to say square root of 2, and I wrote -2. A is the square root of 2 because, like, when you square it, you get 2 right here. Okay. So the integral is 1 over square root of 2, inverse tangent of x over root 2. Okay, so that's 1 over root 2, 1 over a, inverse tangent of x over a, plus a constant.